You can see it now. It's a
But I
really
think it's a bit beyond
that's
my
fine.
knowledge.
I think it's a rotation. We apply rotation. It looks
Mhm.
complicated, but once you break it down, it's not really that complicated. The result's complicated,
Yeah.
but I think
Well, yeah.
we need to explore this together. I don't know the answer yet, to be honest.
Yeah. That's all good. Should we do the spiral first then? Because I don't really mind which form.
Okay. Okay, so we can start with the form first. I can either start with a curve in Rhino, and then we can later on reverse engineer this curve and do it in Grasshopper. Or we can find the form directly in Grasshopper now. Which one do you prefer?
Are we talking about the spiral one or the Instagram one? Like this one?
Anyone? Would you like to do this twisted one or like the spiral one in the example you showed me? This one is easier to do. The twisted one.
Yeah. Okay.
I think that's okay if
Just
you
trying
can't
to
decide.
think.
If you can't decide for the form, I
Yeah.
wouldn't worry about that for now because
Because I
yeah.
also have to 3D print part of it. That's like a separate part.
Mhm.
But I'm just trying to think like I think I was going with the spiral one at first because like I don't want to copy I don't want to look like I'm copying the person that I showed who did the snake form. Because they also did a spiral, but
so when you say
I
spiral,
think there are things.
you're gonna do something like this.
Yeah.
Okay. Yeah, we can do this.
We'll try that one first.
Yeah. I need to start with a very simple script. I need to create a helix. I need to create a helix and I can start with a circle first in Grasshopper. So I can go just type in circle.
Yeah.
There's many ways to create a circle. I can go C and R, and then the radius I can just put in like if it's a 1-to-1 scale for a building. Actually, the scale doesn't matter for now. It's a concept. And then the center will be I can go construct point for a center, and that's my circle there. I'm actually trying. I've not done a helix form before, but I was looking more like I was looking for this in Rhino, like a helix, like this. I want something like this that turns like twice.
Oh.
I was looking more like more. I was looking this script in Grasshopper for helix. If you can't get it now, I will try to. I need to think about it later on. How do you do it?
Yeah. I think I saw this YouTube video. Let me see if I can find it. But I think they did something with the golden angle. Let me see if I can find it. Sorry, give me one sec. But I was following that.
In this tutorial, you will learn how to create different pure interested techniques, and when you click this value, if I change this slide, you can see to 30. This or
I just sent it in the chat, but it was only talking about spiraling. And it didn't really go past the
What if, for instance,
point form,
now,
point and line form.
notice, I would like to.
Yeah.
I'm not sure if
Yeah.
that's
Why?
similar.
Take a look at the output of this.
Point polar. Okay. So how I learn Grasshopper is exactly what we're doing right now. You gotta just watch different videos because there's always gonna be some issues you encounter. Like this point polar, I'd rather use this script. So without looking at the video, let's try to do it together. So if you do point polar, the base is XY, which is by default XY angle of radian. So I think that's the angle that it grows.
Yeah.
Z angle, how much it goes up as well. So it goes up and goes in. So you need X, Y, and Z. Offset, distance for point. Maybe that is the distance in between each point. So let's try
This range.
So in this video he's making the range that counts from 0 to 1. So that's okay. And then he's putting a pi. So the difference is 0.214.
We'll get to 0. So depending, how many turns.
So the reason why he do that is because it will complete one circle.
And green real estate grab, and it's one of the easiest ways to interface turn.
And then I think he added the slider for
you're not going to see any change here.
the radians and how many times it could spiral. That's what I understood.
Actually have name T, but to be called D name will be T. You increase turns.
Yep. So he did a range. So if you do the range, get a habit of using a panel as well to see what are the values. You go to pi, put in a pi format. So the domain means the step in between each numbers.
Yeah. So would like domain also mean like it has 0, 1, 2, 3. So that also indicates the distance of each point, right?
So if I don't put in any value to the domain, by default it's just gonna be 0 to 1. Domain means range in Grasshopper, so that the language gotta understand that Grasshopper when it asks for domain, it's usually 0 to 1, which is a range.
Yeah.
And because of this script here, it's a range script. It's just spitting out from 0 to 1, and each step it will take it will divide 0 to 1 by 10, so it should be 0.1 increments. So this is the range, and this is the number of steps. So if you put in pi, you start from 0 all the way to 10 to pi. So 10 is always the last value, which is, in this case it will be pi. And the reason why we're doing this into the XY angle is because eventually this circle will have to keep moving and it will complete a circle. It has to complete a circle.
Like one revolution.
One revolution, correct.
Yeah.
So I understand. And then later on, he did a golden ratio. Golden ratio is I believe is a pre-built ratio. As a golden ratio has a specific ratio where like a snail, right? A snail is a golden ratio of that shape, the pattern. So yes, I don't really know what this number means, but I know what golden ratio roughly is. So I'll put that into the offset. See what the video did. So he took the pi and put it into the distance, like this. So that's the golden ratio right there. Okay.
Yeah.
So that's looking really good. The proportion looks right. If you want to continue the number of points that it grows, my guess is that currently it's 10 steps. So if you want to do like 50 steps, see what happens. So it's going to increase the number of steps in between. It's not going to increase the length.
Yeah.
So steps wouldn't actually help you. What we could do is that factor to multiply by pi. See what happens if I do 2 here. Yeah. So it's gonna multiply the pi here. Okay. And if I take this point, I put it into a panel. So let's say if I multiply pi by 4, so it'll be 4 pi. So which means that it completes more than one revolution, completes 4 revolution.
Yeah.
Each revolution it increases based on the golden ratio.
Like the distance between the points.
Correct. This is between each completed revolution.
Yeah.
So if I increase the number of points, let's say 50 into the steps, this would be the number of points available. But this is not actually what you want, because in the snake spine, the spine intervals are regular. This one is not, so we can fix that later on. So once we get this point, okay, based on the YouTube. So one thing about learning Grasshopper is that you gotta watch different videos to puzzle things together.
Yeah.
And that's how I learned it. So you get the point polar. So right now we need to create a curve. So to join this all together, we use interpolate. When you try to do something in Grasshopper, there's always like there's always more than one options for you to do. You gotta read the description, what suits you the most.
Yeah.
So and then you gotta understand, see what the script is asking you. If it wants vertices, which is the point, just connect the points together. Okay. So that's looking pretty smooth so far. All we have to do now is to increase the height, give it a height value.
Yeah.
Okay. And to do that, I'm guessing is the Z angle and radians for, so as this circle revolve around it, it's gonna put in a Z angle, so there's an increase from the center. I think. So let's do so normally Grasshopper talks in radians.
Yeah.
But our head, we think about it in degrees. So we gotta do a conversion from degree to radian. Okay?
Yeah.
From degree to radian. So let's say we want to increase by 1 degrees. Okay? But you see, when I put it 1 degree, it's only 0 to 1, right?
Yeah.
And then if I want to change this to 10 degrees later on, I have to do it manually like this. So the shortcut here is you can type in 0 dot 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 10. So it's between 0 to 10.
Yeah.
So it will build in the range for you. So put in this one, 4 degrees. It's gonna increase like this. Okay? But again, this is not what we want. Is the peak is right at the center of this spiral. We want the opposite.
Yeah.
We want the middle point to be the highest, right?
Yeah.
So to do that, we need to think about it in a negative value right now, because this is going in a positive 10 degrees every increment. Positive 10, positive 10, positive 10. So it keeps going up. We want it to go down actually. So we need to give it a negative value. A negative. So what happens if you tell Grasshopper to put in an angle of negative value? What will it do? It will go down. Okay?
Yeah.
Because these are all vectors. So if I put a negative value, it will go down like this. Okay? But then we got another problem. We always have problems. Right now it's below the Z plane. Okay?
Yeah.
Right now it's below the Z plane. There's always a easy way to fix it. There's always an easy way to fix it, and from experience, you always want to try to avoid the easy way to fix because it's not going to be efficient. For now, let's do something that's easier. When it becomes a problem, we can fix it later on. So what I mean is that let's move this point. Let's move this point upwards. Let's move this entire thing upwards so it sits above the Z plane.
Yeah.
Okay?
Yeah.
Okay, I mean, I want to do this, but I'm not really satisfied if I just move this up. Because I'm starting from the middle, I'm doing a negative, so I'm gonna go down regardless. But what if I start from the top instead? Yeah. So the base plane is a problem here. So it starts from the base plane. And let's say I need to start from the top. Okay? If I start from the top, it'll spiral all the way down and it lands on the Z plane. Now I'm not gonna do this now actually, because it's not really a problem. It's just me being OCD, but it's not really a problem. We can get away with it because it'll take time. And we will sort it out next time. So we got the form already. All we have to do now is to divide the curve. Divide the curve now to get all the little points where the ribs are gonna be. And if the thing has 50 ribs, put in 50. I'm sure you've counted the number of ribs. And then, yeah. Divide curve is a very important tool in your project.
Yeah.
It's because it will divide the curve equally.
Okay. Yeah.
And after this one, we need to start growing the ribs on the sides. And And to grow this on the sides, we need a vector. We need a vector to do this. It needs a direction. Okay? And the direction is always gonna be 90 degrees in the direction of the spline. So we need to determine that. So conceptually, we need to understand what we need to do, then we know what to put in the script. So it needs to be 90 degrees from the direction of travel, and it goes in both directions to create the spine. So a tangent, you know what's a tangent, right?
Yeah, when the line meets, it's like when the line meets a certain point in a circle, right?
And it goes in the straight.
Like that. Yeah.
So we can use a tangent, and it'll be 90 degrees off the tangent. Okay?
Yeah.
So let's do a quick rotation. I don't know what to expect, but let's do a quick rotation here. So rotation, you want to do rotation on the, like a very basic flat rotation. So it asks you for vector to rotate. So you gotta convert this into a vector, I assume. The tangent to vector. So you gotta understand what these are, right? If you put in the panel, it's giving you so these three numbers here, it describes a point. Okay. It describes a point. Sorry, this describes a direction. That's what it means.
Is that like the XYZ coordinates of
No,
a
these
point?
are not coordinates.
Oh.
This is coordinates. These are coordinates of a point, and this describes a vector. Okay.
Right. Yeah.
Actually, to understand this better, if I draw a line here, a line can also be interpreted as a vector in Grasshopper as well. It's very useful. So if I have this line, this curve, I put in the value here, a vector. So this curve is just a curve, right? But if I put in the value, what this means is that it becomes a value. So that 0 there is a z-axis, which is flat. And it's like, it talks about XYZ, and Z is flat, so it's going in a direction from X to Y. That's what it means. So it describes a direction, not a point. So that's all we need to know.
Yeah.
So convert this into a vector. You can't just put it directly into here. I mean, you can. I prefer to connect to a vector. And axis, I'll need to be 90, but again, Grasshopper thinks stuff in radians. Okay, put it 90 degrees here. It doesn't like it. So what happens here? Angle failed to collect data from number to vector. Vector to rotate. So axis is what? If I put in 90, what happens? Oh, sorry, this is the angle. Oops. And the rotation axis, it will be XY plane. Okay?
Yeah.
It's gonna rotate on the XY plane like a flat plane. That's why we did. So this is all we need to set up.
Yeah.
So we set up the rotation. So we have rotated the vector. So all we need to do now is create a line SDL. A line SDL is a very primitive line where you have to start from scratch. So it starts from the point, direction, it will go onto here. So we have completed one side. We need to do two sides. Okay?
Yeah.
Now to do two sides, it's very simple, but you have to understand again, it's about the language of Grasshopper.
Yeah.
Grasshopper thinks that is 1. So 1 is a positive value, so you choose the positive vector direction, you put in 1 unit. We need to tell Grasshopper that we want to do from -1 to 1, so it covers from the negative to the positive 1. Because everything on the left side is positive, anything on the right side is negative. But I don't want to complicate stuff for now. I'll just do two lines. We can just join it up together. One line will be a negative direction. So I'll flip the direction. I give a negative, so it goes into 2 different directions. And I can just join the curve together like this. Okay?
Yeah.
So that's cool.
I'm just wondering as well. I was talking to my tutor about the little lines, like the little rib spines, or the little ribs on the spine. He was mentioning like if I'm able to figure it out, I could even put multiple points on those ribs and then be able to change. Like if I do, I think the prompt is pipe, like you make them all like 3D like tube looking things. Would I be able to change like the thickness of them and like start manipulating like how they physically look as well?
So you can do a pipe on the actual spine. And pipe is a very easy to use tool. You can put a pipe here. The only thing is that it will slow down your computer. But at this stage it's fine. The radius can be like 5. So 5 unit would be 10 diameter, for example. So it's pretty thick. So just be careful with that one. So if it's a 1, so 1 is pretty thick as well. Let's say you can also do floating numbers. So floating point means you can go into decimals. So you can really fine tune that. So you can go in between 1, like 0 to 3, and then taking this radius, you can also put it into here for the sides, and this will be obviously thinner. So you can do a couple of stuff here. Things like this we need to fix it up. We need to refine the script to fix things like this. It happens all the time, but that's okay. I think this one is normally gotta do with how the circle starts.
Like it looks like it started exactly on
0, so it has to take the tangent off that. So that's why it's happening. But that's okay. There's always gonna be like a few imperfections, and so this is how it is right now. You can also start to add in some arch here, because the ribs is not actually straight; it's actually arching, right?
Yeah.
So we can do that as well. We can go to an divide curve again. Divide curve, but this time we want to do 3 points. Take 3 points. 2. So you get 3 points on center and the 2 sides. Not really sure how to do this at the moment, but I'll just try to do if I do this quickly, I think I'll go endpoints. What I'm trying to do is that I'm gonna bring down the two endpoint and connect it like arch.
Yeah.
So I need to bring this down. We're kind of running out of time, but I'll just do it quickly.
Okay.
So I'll just bring it down by 2 units. So currently it goes up. So I need to go negative to go down. Okay, we can always put in a random value later on, so it goes down by a random number. So it's like, in nature, things are always not perfect. So there's always like a couple of variations. So that's what I'm trying to say.
Yeah.
So let's say it goes down by this much, and then I can go panel. So the problem is, we can talk about this next time, but listing is very important in Grasshopper. This is a flat list, and I need to graph this list so that everything sits within its own list.
Oh, wait, I don't think I've learned grafting yet. What does it do?
So grafting, so listing, so think about information. These are all just information in Grasshopper, okay?
Yeah.
It's not aware about its form, it's just information. And information are sorted in the list. So this, when we look at this one, this is one list that contains 35 curve. That's what I'm saying. This is one list containing 35 curve. And if you look at, I think, how do you preview tree? Tree items, sun is there. So if we go tree branch, yes, the comment. If you can't find it, then next time. Tree branch. Yeah, can't find that. But currently this is one list that contains 35 items. And if I graph this, graphing means that it is one list that contains one item. So every item is sitting within a list. Okay?
Yeah.
That is what it means. It's like saying you got 50 students. Do you put one student in each bus, or do you put 50 students in one bus? That's what it's saying. Okay?
Okay.
I usually go to simplify. If the branch becomes too complicated, I'll go simplify. And what this means is that if I graph this, every curve it's isolated. So the curve wouldn't talk to each other, because I don't want it to talk to each other, right? I want to create an arch within its own like points, correct? So this is keeping the data clean. If I graph this, and the reason why I need to graph this is because when I do the endpoint, it comes out two separate points within its own list. So what's happening here is that for one curve from its own list, it creates two separate points within the same list. Okay.
Mm-hmm.
So it's like saying if I put one student in one car, and that student split into two students, it's still within the same car. One car.
Yeah.
So I can manage this by looking at the cars rather than the student. Because from one point, I need to create 2 points, the start and the end point. So which is contained in the same list. And this is important because I need to dispatch this. This is where things becomes, it can be confusing. So I need to dispatch this. Dispatching means that I can, A and B means 0 and 1. Dispatch means I can divide it into 2 separate paths. And the reason why I'm trying to do this, I'll just explain. Because this is 1, so there'll be 1 point here, 1 point, and the third point, 1, 2, and 3. Okay? I'm trying to create 1 point that goes down, keep the same point above here, and the third point that goes down. I've already created these two, and I need to join up like this.
Okay.
Okay, so I need to make sure the sequencing is correct. So this is 1, 2, and 3 for it to draw a curve, because the curve is based on the sequencing of the points.
Yeah.
So the reason why I did dispatch is because I can identify which is the first point. I can go to merge. I can start constructing this now. I'll go merge. That is the first point there. The second point should be the middle point. So go back to my, so I have it somewhere here. Find out that this is the point here. Okay, that's the point.
Yeah.
The point for where this thing all starts from. But just be careful, this is a flat list. I need to graph this as well. Okay?
Okay.
Because I need to represent this all within its own list. Graph. How to spell graph? Graph tree.
Yep.
Okay, I need to graph this. Put it into my second point, and the last point is here. So last thing I can do is that I can interpolate this, and this is awkward. What's happening here is that, yeah, the problem is about branching as well, because this is 0. It says here the point is 0, but this has like 0, 0, 0, 0. So it has 4 branch. We can talk about branch later on. If I simplify this, is coming down to the first branch. You're just gonna make sure the branch is correct. So the channel is, I think it's important to understand branching in reviewing graph. Grasshopper. This one here, that's what it means. Creating data tree. Yeah, this is important stuff here.
Yeah, I think I think it might have been last week's tutorials, because they also upload videos additional to what we do in class, and they started on data trees, so I haven't really started on that. Yeah,
data tree is like, it's boring. It's kind of boring.
Yeah,
it's one of those things you fall asleep, but it is important. It's like understanding how do you package things together so that if things are not packaged properly, it wouldn't connect. So this means that you have one data sitting in one list. That's what it's saying. Okay? Let's say if I flatten this, if I flatten all this stuff together, let's say if I flatten this curve together, this curve, all this curve,
Yeah.
then everything will exist in one list. That's what it's So one line means one list, and if I do not simplify this, it's still one list, but it's talking about it's a subset. All this stuff is a subset of a
Yeah.
branch. So anyway, we got our arch here, and we can also do a pipe based on this arch. And I will just hide all this stuff because we don't need this. So there we go.
Yay. Oh wow.
Increase. Yep.
I have a quick question.
Mm-hmm.
Would if I wanted to make like the middle of those ribs like fatter,
Yep.
does that make sense? Like, is that a whole nother?
It's about parameter. It's called pipe variable. And this tool, again, you have to understand parameters.
Yeah.
In Grasshopper, there's there's like 4 main things you need to understand. Parameters, vectors, lists,
Yeah.
which is this kind of stuff, the list,
Yeah.
and vector, parameters, lists, and domain, was it? Range? Something like that. Range. Everything operates in this kind of language. So this is parameter. So this is important because if you put in a pipe variable, you do a pipe, it's asking for the parameter because it's basically saying if you do a panel, or let's say you do like this is a fancy tool you can use, a gene pool. Gene pool is actually I'm not gonna use this one. Let's do something basic. Let's do a panel. Parameter means that say from 0 it's gonna be, we divide this this spline into 0 to 1, but let's say you give it a middle value 0.5 to 1. Okay, there's many ways to do this. And then the radius, and this is a radius for every defined parameter. So you can say the radius here is going to start from 0.3, and then it grows to 0.6, and it grows to 0.9, for example. So parameter means you are dividing this curve from 0 up till like 0.5 here, 1 here. So parameter doesn't care how long the line is, it thinks about it in terms of 0 to 1.
Yeah.
And if you put a parameter, it's important for Grasshopper because it can identify at which point is that 0.5. And then you can put in the radius that corresponds to the parameter. So at 0, it's going to be 0.3 radius. At half of the line, it's going to be 0.6, and so on and so forth. Put in the radius, and yeah, this is very important. So currently it's not working, right? It tries to do the 0.3 to 0.9, but it only starts from the first loop. That means the first.
Yeah.
And it's very common because because currently Grasshopper thinks that this is not 0 to 1. 0 to 1 only exists here. Like it exists 0 to 1 here. So so Grasshopper thinks that 0 to 1 in this area. So you need to reparameterize the entire curve. So reparameterize means that you can tell Grasshopper, hey, actually this is the entire length that you need to calculate.
Yeah.
So if you do reparameterize, if I type this one, so it's gonna be thinner and fatter at the bottom. So, which is not what you want, right? You want to start from 1, then goes from 0.8 and goes to 0.3, for example, something like this. Okay.
Yeah.
This is the easier way to do it manually, but it works.
So if I wanted to do that, like same logic with the actual what do you call it? Like the ribs, like the little arches, would I do pipe variable as well? And
correct. Pipe variable, put in the parameter.
Yeah.
Put in the parameter. Yeah. So if it's if the sides are going to be thin, you go 0.3 on both sides, and the thickness will be 1, like this.
Oh, okay. Yeah.
This looks funky. I like this. Yeah. Very using. Oh my god. Yeah. And then bonus tip for you. You gotta give it some colors to represent a diagram. So I always put in a color swatch. I always do a custom preview, so things becomes a color that I want to differentiate. And then the bigger ribs will be a different color to like identify what is primary and what's secondary. So yeah, you get the idea. Okay.
Yeah.
This looks very. Yeah, I feel uncomfortable looking at this one. But yeah, this is the base of the script, okay? And there's many things you can do with it. Yeah.
Wow.
Everything here is fully customized.
Yeah.
But it's gonna be more complicated from this point on. Okay, we can even do like the arch is gonna be thinner as it comes out, or we can do like random variables, so not everything is consistent. We can even do like unproportionate thickness. Yeah, there's many things to do with. You can even change the form. Yeah.